Assalamualaikum and a very good day. My name is Nur Hidayati binti Rusli. My matric number is P0918100320. I'm from Faculty Mechanical and Manufacturing Engineering Technology. Today, I want to present my Bachelor Degree Project 2 that titled The Study of Design and Analysis of Impact EPS Form for Crashworthiness Vehicle. My supervisor name is Encik Muhammad Hidayat. The outline content for my project presentation today are introduction, objective, scope of the research, methodology, result and discussion, and lastly is conclusion and recommendation. As for introduction, the study of automotive crashworthiness has become a significant research topic as manufacturers seek to create safer vehicles that can avoid fatal injury to passengers in the event of a collision. By time changes, many vehicle manufacturers compete in the automotive industry to produce better vehicles with significant quality in terms of efficiency and protection. Impact EPS foam is chosen since it is one of the best energy absorber foams which is widely used in automotive and aerospace applications. Then, to increase vehicle structural integrity, different types of foams are used in various parts of an automobile. Next is problem statement. Vehicle crashworthiness can be improved by using energy-absorbing foam. There are many studies of crashworthiness of vehicles can be found in the literature. However, there is a limited public research on using impact EPS foam for impact energy absorbers for vehicles. In this research study, there are two objectives. First, to apply the different densities and sequence of impact EPS form with variation of impact velocity through simulation. Second is to study the best design configuration of impact EPS form based on one meter stress, strain, and displacement result. Next is scope of project. First, to investigate and review research on impacts EPS foam application as energy-absorbing materials. Second, to study the research and crashworthiness of vehicles to analyze the important parameters such as material properties and other information from published research results. Third, to perform numerical analysis on combination layer of impacts EPS foam in SolidWorks software. And lastly is to analyze the research simulations finding. Then we move to literature review. This study will focus on two automotive closed cell energy absorption foam material, since it is a highly engineered polystyrene-based thermoplastic foam. Impact foam is created through extrusion process and combined with blowing agent and other additives. Impact foam is commercialized with three grades, which are Impact 300, Impact 500, and Impact 700. It has closed cell structure, and it is known for its lightweight and good impact energy absorption. Next is deformation mechanism of foams. The application of closed cell polystyrene foam will be focused in this study. Major structural characteristic of foam is the proportion of open and closed cell as well as the relative density. In compression testing, the stress strain response of foam reveals certain similar characteristics for many types of foams. The greater density foams have younger Young's modulus. Next is stress strain curve of impact EPS foam. Figure shows quasi-static stress strain curve of impact EPS foam. The material is characterized as a high-efficiency energy absorber because the stress strain curve is almost a block curve and good absorbers show a square wave response. The next graph shows a comparison of impacts and conventional material during quasi-static compression at the same density level of 48 kg cubic meter foam. PU and EPP are clearly less efficient than impacts EPS foam. This figure shows the technical data for impacts EPS foam. Then, this flowchart shows the methodology of this research. It started with literature review, then material modeling, after that simulation of impact test, then collecting the data and group all the finding, and lastly is conclusion. As for material modeling, the parameter required to develop the model for each form are length, width and thickness. The value of the parameter are length 107 mm, width 107 mm, and for thickness is 55 mm. Figure shows the density of impact form. Then the form will be simulated as stacked layers with various density configurations. The six combination layers from which are ABC, ACB, BAC, BCA, CAB, and CBA will be modeled in software SolidWorks. After done the 3D modeling, simulation of impact tests were conducted. The finite element model of impact test is developed in SolidWorks software. It consists of a form model, an impactor, and fixed plate. Impactor and fixed plate made up from steel, and low density form is used as a material model. Mass for impactor is 14.25 kg. After completely fill in the parameter and done the meshing process, the simulation for impact test will be run. Based on this table, there are 18 material designs since the simulation will be performed with 3 different impact velocity, which are 6 meter per second, 10 meter per second, and 15 meter per second. This is the material properties of impact EPS form that has been used for simulation. As we can see, the minimum and maximum values of one meter stress for material design CBA is same when it impacted at velocity 6 meter per second and 10 meter per second. And then this table shows the minimum and maximum values of strain. All the data is obtained from the simulation result. Next, this is the comparison of maximum bond meter stress for material design ABC, ACB, BAC, BCA, CAB, and CBA. By referring to the graph, material design CBA, as you can see in the graph, it shows that it has the highest value of 1 meter stress compared to the other material design after impacted at 6 meter per second. However, at 10 meter per second of impact velocity, the material design CAB produced high value for 1 meter stress, and the lowest value is material design ACB. When the layered form is impacted at 15 meter per second, the maximum 1 meter stress of material design ABC and ACB is about the same with not much different. This situation may occur due to many aspects and mesh size. When the simulation is simulated, there is some effect of design on mesh size. The mesh size may be too small or difficult to control. And now, this is the comparison of maximum strain for material design ABC, ACB, BAC, BCA, CAB, and CBA. From the graph, the maximum values of strain with impact velocity 6 meter per second is occurred on material design CBA, and it is different for impact velocity 10 meter per second and 15 meter per second, where the highest strain is occurred on material design CAB, which are 7.157 exponent negative 0.2 and 2.317 exponent negative 0.1 respectively. Based on this finding, the study concluded that the highest value of strain occurred on combination layer of the material design that included a component of material C. After that, this is the result of the maximum point of displacement for every impact velocity. As you can see on the graph, The highest displacement result for impact velocity at 6 meter per second is material design CBA, which is 11.38 mm. It is slightly higher than other material design. For impact velocity at 10 meter per second, material design CAB produced the highest displacement, which is 13.54 mm, while the impact velocity at 15 meter per second is material design CAB with 25.57 mm. As for conclusion, the objective of this research study has been successfully achieved. It has been discovered that material B should be placed in the middle or top position compared to material A and C to achieve the best result. Material C has a significant impact on material combinations. Material C should be placed in the middle or at the top of the design configuration for maximum optimization. To sum up, material design ABC, material design CAB, and material design CBA were selected as the best design configuration. And lastly, all the material design are safe, since the value for maximum 1 mesostress is less than the value of yield strength. Last but not least, some recommendations were made through the experience gained from this research and for future consideration. First, conduct mesh size analysis to see how mesh density affected the simulation result. This is an important task because it will reduce the computation cost without compromising the simulation results accuracy. Second, in the automotive industry, a similar statistical approach can be applied and used, and particularly to increase the roles of passive impact device. Lastly, in order to get a better understanding of the dynamic characteristic of foam, it is also necessary to consider energy dissipation by the material. That's all for our project. Thank you.